Alrighty. So these look kind of weird and kind of scary a little bit, but I promise these are not bad. And this is really, really closely related to what we're doing today. So I've got 2 minus 3x plus 5 plus x. What are we going to do over here? Are these parentheses actually doing anything here? Nope. So this is just like saying 2 minus 3x plus 5 plus x. And what are we going to do? How can I simplify this? Yeah, we're going to combine some like terms. I've got the 2 and the 5. We've got a positive 2, positive 5. That's going to give us 7. And I have minus 3x and plus 1x. So minus 2x. I will make those brackets unsquiggly because I feel like that's bad. There we go. That's easier to read. Okay, so it's just combining like terms. On the second one, what are we going to need to do? We're going to have one step before it comes to the combined like terms. What do I need to do here before I can combine like terms? Say it a little louder. Take out the parentheses, but in order to do that, what do I need to do? With this, with the minus sign. I need to distribute the minus sign through because we're subtracting that whole piece. So it's going to be 7 minus 3x minus 6 minus 4x. We're subtracting the whole chunk. So you've got to distribute that minus sign through, and then we can do exactly what we did on the line above, which is combine the like terms. I've got a 7 and a minus 6, leaving us with what? 1. And I have minus 3x and minus 4x. Yeah. 1 minus 7x is what we have. And I'm just going to write it up here so I have this space for the next one. And this is as simplified as we can go on these. So when it's adding or subtracting, it's just combining like terms. With subtraction, we have to distribute the minus sign, but then it's the same thing. For the bottom one, you have a couple of options. This is multiplication. So it's not just combine like terms. We're either going to need to, oops, wrong pen, distribute, where we do this kind of guy. If that looks familiar, great. You could box it and multiply this way, where we take our 2 minus 3x times 5 plus x. Either way, you should get the same answer. We're going to take, I'm going to do it in the box right here since I have it. 2 times 5 gives us 10. Ooh, that's not the laser pointer. 5 times minus 3x gives us minus 15x. X times 2 gives us 2x. And x times minus 3x gives us minus 3x squared. And then to get everybody out of the box, we pull them all out, line them up by adding all the pieces together. So we're going to have 10 minus 15x plus 2x minus 3x squared. A lot of pieces in those two steps. Everyone see what we did there? Because we have one last step. What can I do to simplify this further? The negative 15 and the 2 are both plain x's. So I have 10 minus 15 plus 2 gives us minus 13x minus 3x squared. And that is a perfectly fine answer right here. Bless you. Okay. Questions on these three? Because this is what we're going to do today. We are going to do these two things. We're going to add, subtract, and multiply. But this time, instead of having a x in that place, we are going to have an I in that place. I'm sorry, there we go. An I in that place. So it's the exact same concept. You're going to add things together, subtract things together. They just have I's in there in place of the X's. We treat it exactly the same. So we've got 8 plus 3i minus 4 minus 10i. And this is just like that one we did in the bell work that had the minus sign on it. So we're going to start with distributing the minus sign through. So we're going to have 8 plus 3i minus 4 plus 10i. Distribute the minus sign into the second piece. And then we're going to combine like terms. I've got an 8 and a minus 4. Those are going to combine together to give us a 4. And I have 3i plus 10i giving us plus 13i. Bless you. It's very snizzy out today. And that's our answer. That's where we stop. When we are adding these pieces that have i's in them, we're going to wind up, for the most part, with i's left over. And it's going to look like this. And that's okay. It's supposed to look like that. But this is what it looks like when we add or subtract these complex numbers, these imaginary numbers. That's our answer. But we treat it and do the exact same steps we would if that was an x. It's just an I this time. We're going to do another one. I don't like this piece being here, so I'm going to cover this up. Give me a second. So the next thing we're going to do is we're going to do the same thing. But this time it has minus 5 plus 5i minus negative 3 plus 8i. These are called complex numbers because they look kind of complex. Same vibe. I'm going to take my minus 5 plus 5i, and we're just going to bring that down. And we take this minus sign and we distribute it through. So that we're going to have plus 3 minus 8i I. From here, we're combining our like terms. I have minus 5 and plus 3, giving us minus 2. And 5i minus 8i, giving us minus 3i. Okay, how we feel with these? They have eyes in them, but we're not doing much with the eyes. They're just kind of hanging out. The adding and subtracting of complex numbers where we have these eyes is very similar to when we have x's there. We treat it exactly the same. So we didn't do an adding one, so I'm going to make up an adding one real quick while we've done a subtraction. So let's do, we'll just take these ones. Let's do negative 5 plus 5i plus negative 3 plus 8i. Let's do an adding one, because we haven't done an adding one with these complex numbers yet. But it's the exact same vibe. This time we just don't have any parentheses or any minus sign to distribute through. So now we just have our minus 5 plus negative 3, which is going to give us what? Negative 8. Then we have 5i plus 8i. What's 5i plus 8i? Five ice creams plus 8 ice creams. How many ice creams? What's 5 plus 8? $13 ice creams. Just because it's an I doesn't change what we do. So adding and subtracting when there's i's there looks really scary. But it's exactly the same as what we would do if there were x's there. It's exactly the same. We've been working with x for a long time. I just looks really, really scary. The only time it gets any harder is when we do like our third one on the bell work, where we're going to start looking at multiplication. It does get slightly more complicated here. So we're going to do 2 multiplication problems, and then you'll have the rest of the time to work on that homework that I gave you, because it's most important that you practice this. Okay? And you have a couple of options when you're coming to multiply these things. You can distribute it or you can box it, and I don't care. I will do one of each, just so that we see both. Okay, so I will do the left one with a box, because y'all seemed really comfortable with the box on the first one. So I'm going to take my 3 minus 6i times 5 plus I. And we are going to multiply in. So we take our 5 times 3. What is 5 times 3? 15. 5 times minus 6i. Negative 30i. The i's still there. Then we're going to have our 3 times I, which gives us 3i. I. And then our last one, we have minus 6I times I, which is going to give us minus 6I squared. I times I is I squared. So then what I'm going to do is I'm going to pull everybody out of the box and add them together. If we forget what operation it is, there's a little plus sign right in the middle of our box here. Helps us remember that we add everybody together. So we're going to have 15 plus 30I. And I'm going to need to give us some more space here. There we go. Oh, sorry, but it's not plus 30I. It's minus 30x. That's negative. Plus 3I minus 6I squared. We talked about I squared on Friday. Anyone remember what I squared equals? I squared equals negative 1. So this is really negative 6 times negative 1. So we have 5 minus 30I plus 3I. So let's combine these like terms. Minus 27I. And then minus 6 times minus 1 gives us plus 6. And we have one more combining like terms to do. What can we put together now? I can combine together the 5 and the 6 to get 11 minus 27I. Yes, dear. Oh, you're right. That should have been 15. That is a mistake. That is 15. Boop. So it should be 15 plus 6. So what should it be instead of the 11? 21. Oop. That's what happens when I have my iPad scrolled in too far. Cut off that one on it. Okay, so it's just like when we do these things with x's. We treat them the same. The only thing that's a little bit wonky is this I squared equals negative 1 piece. It's the only piece that's weird. I'm going to do the right-hand one with distribution, for those people that like distribution better. I do not care which process you do. If you are a box stand, box it every time. Go for it. 100% it will work. If you are a distribution fan, go ahead and do that one. It will work every time. You should get the exact same answer. I just like to show you the options that we have. So we're going to do this one. I'm going to take my 2 times 2, and that gives me 4. I'm going to take 2 times minus 3I to get minus 6I. I'm going to take my 3I times 2 to get plus 6I. And I'm going to take my 3I times minus 3I to get minus 9I squared. I know the blue and purple are really close together, but we can still kind of see what's going on here. If you were to box this would be the numbers that you would find inside the box. So it gives you the exact same answers. The exact same. I feel like this is the easier way to write it, but it's a matter of keeping yourself organized sometimes. Because then we're going to come in here and we're going to simplify. What happens to my i's? They cancel out. And that's totally fine. So we're left with 4 minus 9i squared. What does I squared equal again? I squared equals -1. So what we really have is 4 minus 9 times -1. 4 plus 9. What is 4 plus 9? 13. So there are going to be times when you wind up with answers that don't look better. And there are going to be times when you wind up with answers that do. Our answer here is 13. Our answer could be just an imaginary number, or it could be a mix of both. That's called a complex number. But that is what is on the back of the homework that I gave you guys on Friday. Are these. And so I wanted to give you time to work on them because they're not super complicated, but they are sometimes tricky to get your brain to wrap around them. So we need to practice them. Okay? We will do a little bit of notes tomorrow, but it should be review from Algebra 1. So, but then it'll be getting ready for the quiz on Friday. Okay? So that's kind of the plan for the week. You guys have the rest of the time to finish up homework. It's 3-3 is the one I gave you guys on Friday. 3-3. Okay. Oh, that is not it. This is called I haven't updated my slides yet. So we're going to have a quiz October 6th, which is Friday. So we have a quiz coming up on Friday. I will get you guys review probably tomorrow. All right, so use this time, work on stuff. You guys have a solid 20 minutes to the end of the period, 15 minutes until the announcements start. So use this time, work on stuff, ask questions, all that jazz.